So now we're at my desk. I can show you what you're going to need for the electrical circuitry and then what the tools are that you need for this part of the build. Obviously, since we're making a light, we're going with LED strip. Self-adhesive, always go self-adhesive for this. It just makes your life easier. You could go with something as simple as, if it's not a smart light, you go with a remote control model where you just set the color of the light or the pattern with that remote control and go from there. Since we're going with smart, we're using the WS2812b style strip. Pick that one specifically because there is a library out there for use with Raspberry Pis. This is the 5-volt model. It's also a cheaper strand than some of the other options you've got out there, so this is nice entry level and will give us good illumination. This is a addressable LED strip. Basically, I can choose what each LED emits for a color. To go with that, obviously, I've already given it away, we're using a Raspberry Pi. The Raspberry Pi we're using is the Pi Zero wireless model. That way we don't have a bunch of extra cords. It's going to keep it nice and neat. For the Raspberry Pi, you're going to need to have a SD card, 8 gigs minimum. I'd stick around that capacity for this. You can do 32 gig, but that's going to be overkill for what we're going to be doing in this project. Micro SD card reader. Enclosure, this is not required. I'm just using it to help button things up, make it nice and neat. 5-volt 4-amp power adapter. Just for this project alone, this is me looking into the future based on some readings I took. Basically, you're going to need to take readings to know if this is the right size for you. We originally started out with a 10 amp because based on the ratings on the packages, that's what we would need. But I'm reading something a lot less than that, and we also used less LEDs on the strip. So we're going with that. For the tools side, soldering iron, solder with Rosin core, so that way we don't have to use flux, wire strippers. So now that we have that all listed out, let's get to setting up our Raspberry Pi. First thing you're going to want to do is take your SD card in the reader and plug it into the computer. Alright, so now that we have our SD card inserted, I need to format it. Format complete, close, completely ready for us to use. Close that. We're going to go over to the web browser. You're going to go to raspberrypi.org to download the Raspberry Pi OS. You go into the software tab, you can actually see that they now have a Raspberry Pi imager. You're going to go ahead and download that. I already have it downloaded. We're going to choose our OS. That's going to be Raspberry Pi, 32-bit. We're going to choose our storage device. Remember, it was F. Make sure that you don't choose the wrong one or else you'll overwrite your data. So now we hit write. And that will write to the disk and do everything we need it to. Alright, so now that we have our distribution of Raspberry Pi OS on the SD card, we might need to eject the media and put it back into our computer just for this to show up. But you're going to go over to your PC and you'll see devices and drives and look for the boot disk. And that is where our Raspberry Pi OS lives. I'm going to open that up because what we're going to do now is add 2 files that will allow us to run this in headless mode. Headless mode is where a computer is operating with no peripherals. Basically, all the control interfaces that would be normally attached to it aren't there, hence no head. The reason why we're going to do this today is because I don't have any room to set up a monitor and keyboard and mouse to plug directly into this board. Also, I need to use some adapters. It's just too much of a pain. I've already got a really nice desktop PC that I can use and we'll just remote in that way. So the two things we're going to have to do to set up headless mode is we need the Pi to be able to get onto our network. And since this is a Raspberry Pi Zero, it needs to be a 2.4 gigahertz network, not a 5 gigahertz network. Only if you're using 3B Plus and 4 do they have dual band on them. Anyways, what you need to do is we're going to add our first file, and you're going to do that by right-clicking, do New, Text Document, and we're going to name this WPA underscore supplicant. SUPPLICANT. Enter. Then we're going to open this file up, and we're going to put ctrl interface, so CTRL underscore interface, all lowercase, equals all uppercase, DIR equals / all lowercase from now on until I tell you otherwise, var, VAR, / run / WPA underscore supplicant space. Now this, we're going to write group in all capitals equals netdev, all lowercase. Then we're going to put update underscore config equals 1. Then country equals US, and US is capitalized. So for these first three pieces of code are required for this to be a valid WPA supplicant file. It's basically saying, hey, I've got this config file called WPA supplicant that I want you to update your configuration with. There's one of them, and we happen to be residing in the US. This is important if you are using 5 gigahertz. They need it for setting the frequencies properly. Since the system always looks for these no matter what, you need to have them in place. Now for our network credentials, we're going to go and put network equals open curly brace, then go down to the next, and you're going to put SSID equals open quotes, and you're going to put whatever your network is that you're trying to connect to. So I'm not going to put in my credentials just for security purposes. For the example, I'll just put your network name, close those quotation marks. Then we're going to put in our password by doing PSK, all lowercase, equals open parentheses. Obviously this is not my password, but just so you can follow along, I'm putting it in there. And now we're going to put in the security type. We do this by doing key underscore MGMT equals, and you're going to put like WPA, WEP, whatever it is. Mine is WPA2. So you would think that it's WPA2, but it's not. It's actually WPA, all capitals, dash, all capitals again, PSK. Now, I'm using WPA2 personal, but that doesn't matter. Personal or enterprise level, it's still dash PSK. And then we're going to encapsulate this with our close curly brace. So now that you have that, you're going to save this out. And then we're going to go over to the .txt extension on the WPA supplicant file, and we're going to change that to conf, and that means it's going to be a config file for our system. You're going to hit enter, and Windows is going to freak out. That's okay, because we're messing around with the extension, which changes how the computer views this. And we know that it's supposed to be conf, so we're going to say yes. Now that our little computer can get online, we also need to let it know, hey, it's okay for you to accept SSH remote connections. And it's pretty simple to do that. We're going to right click, go to new, do another text doc, and then we're going to select everything including the .txt extension and just type in SSH. This can be all caps or all lowercase, it doesn't matter. Hit enter, watch Windows freak out again, hit yes, and it'll say, hey, I've created a file of unknown type that is SSH, and that's fine. So now we have these two. Now obviously, For me, this config file is not going to work because it has that code that I wrote for you guys to just follow along. So I'm going to go into my folder, take my actual supplicant file, and drop it in there. All right, so now we are on the same page. I have legitimate credentials in there and my SSH. What you're going to do is go into your system tray. There's going to be a little USB icon, and it'll be safely remove hardware and eject media. And you're going to eject the one that's containing the boot drive. All right, so now that we have our ejected media, the SD card, we're going to load this into our Raspberry Pi. Don't make the same mistake that I did, which was to try to power this off the USB on my computer. It's not quite enough power to run this reliably. I've found that Raspberry Pis are most stable around 2 to 2.5 amps, and when I tried to power this off of the computer, I was just running into some weird issues where it wasn't connecting. So make sure you use an external power source with 2 or more amps of output. There are 2 different connections you can see here. One is marked USB and the other one is marked power in. Make sure that you're plugging it into the right one. If you're trying to do something where you're communicating with it through USB, it has to be the innermost one on the Raspberry Pi Zero. If you're just doing power, you have to go on this outer one. So I'm going to plug that in right now. As you can see, we've started having blinking on the status light. It's going to be a little bit irregular. This is going to take about a minute to a minute and a half to come up. Wait for the status light to kind of settle out to a solid green, and that means that everything's pretty much done. It's not processing. Bring up my router. Do this by doing 192.168.1.1, and that is anybody's home router. If you're attached to it, that is the home IP address. Brings up my router. Now I'm going to bring this off screen so I can sign in real quick, and then I'm going to bring up my device list. And so I have my device list here. So I'm going to set the client name so that way it's showing what these devices are saying they are. And I'm going to go all the way down, and you can see already the Raspberry Pi is shown up here. The important part is this IP address that we see here. Now this IP address is how we're going to talk to the Raspberry Pi. Some people use the host name. I have not had good luck with that. More reliable way is to use your IP address. Open up PuTTY or whatever you want to use. Hyper is another one that you can use. And we're going to take this and put it in for the host IP. So mine is 192.168.1.218. Hit open. And as you can see, it brought up a terminal window and it's asking for login credentials. For the first time that you set this up, it's going to be Pi, enter. If this is the first time that you've used this, then it's going to be Raspberry. So what we're going to do now is change the configuration. We want the host name to be different and the password to be different, because as you can see, if I know what the default password is, anybody else who has used Raspberry Pi knows what the default password and credentials are. So the way you do that is you use sudo raspi, RASPI -config. That brings up this screen. System options, go down to host name, enter. And as you can see, I've already changed mine from Raspberry Pi. It is now offline Dino light, because that is what this device is going to be. You can change it to whatever you want for whatever project you're doing. If you don't like this name, that's fine. I'm going to hit enter and it accepts it. Then what we're going to do is go back into system options and go down to password. So we're now entering a new password for the Pi users. It'll ask for the new password. Type it in, hit enter. It'll ask you to retype the password, and it'll tell you if you did it right or not. If they don't match, then you have to do it again. Hit enter. So now we've done that, what is a just good thing to do is update. You run this, let it go all the way through, and then it'll be like, all right, I'm all up to date, and it'll bring you back to this screen. I've already done this, so I'm not going to waste your time with it. And then you go down all the way to 9, and then you hit right to get down to select, and then right again, and that gets you over to finish, and then you hit enter. Would you like to reboot now? Yes. This finalizes all of our settings. Then you get a PuTTY error, which is fine, because PuTTY wasn't expecting the network connection to close, but we were, because we just told our Pi to restart. So now we can close this, and then what we're going to do is just wait a little while, open our PuTTY back up, and we have our login prompt. And now you're going to use still Pi, but you're going to use your new login credentials. And there you go. So now we can move on to adding the libraries that we need to run our WS2812b lighting. First thing we need to do is make sure that indeed everything is up to date. So we do sudo apt-get space update. And this is going to go out online. Make sure that our Raspbian is all up to date, has everything that we need. And that'll take a few minutes. So now that that's done, we're going to install the required packages. Sudo apt-get space install space gcc space make space build dash essential space python dash dev space git space scons. Expand this out just a little bit so that way you can see what I'm writing here. Space swig. Enter. It's going to go out and get this package. You're going to hit Y, enter. It's going to do a bunch of unpacking, preparing and unpacking and setting up and installing. And once your green bar shows back up, it's ready for the next command. And we're going to have to disable the audio output because of how we're going to be controlling the LEDs. So we're going to put sudo space nano, and that's the text editor app. And then we're going to do /etc/modprobe.d/blacklist.conf. And so basically what this is doing is telling Nano, hey, we want you to open and we want you to open up the SND blacklist configuration file. So hit enter. And so right now nothing is blacklisted. We're going to add a new line, blacklist, all one word, space SND underscore BCM 2835. In order to have this saved, you're going to do Control O and then enter, and then you're going to do Control X. Now we need to edit the config file. So we're going to do sudo nano again, space /config.txt. Hit enter. And what we want to go do is find the enable audio. And you can do Control W to search. And we're going to put in what we're searching for. And that is going to be pound space capital E enable space lowercase a audio. And I'm just going to search for that. So I'm going to hit enter. And that shows the part that we're actually looking for, which is enable audio loads SND underscore BCM 2835. We want to comment out audio on. To get down to that area, you can't click. You're going to have to use the arrow keys. So click down, then you're going to do the hashtag or pound symbol, and that makes that a comment. Basically, it's going to get ignored by the system. Save. So you're going to do Control O, enter, because we want to rewrite the config file. Control X to close out, and sudo reboot. And this is going to restart our system with the new configuration in place. Now we're going to download the library that will actually let us run the LEDs. Git space clone space https://github.com/JGA/RFF/RPi_WS281X. Hit enter. And this is basically pulling all the code from that gentleman's GitHub and pulling it onto our Pi for use. Since we're going to be running this in Python, we're going to compile the C code into Python code. So we do cd, aka change directory, to RPi_WS281X/, and now you can see we are in that directory. And you're going to do sudo scons, enter. We're going to wait until our prompt goes through to allow us to give more commands. And there we go. Now we're going to do cd python, and now we're going to do the installation. So that's going to be sudo python 3 setup.py space build, enter. And now that our prompt is back, go sudo python 3 setup.py space install, and then we're going to do sudo space pip3 space install space adafruit, ADAFRUIT dash circuit python dash neopixel. And now that that is done, we can go ahead and do a test. And so what we're going to do is go sudo nano examples /strand_test.py. And so what we're going to need to do here is look at how many lights you have on your strand. Alright, so mine has 150 pixels. Click into my window, go over here, and change this to 150. So now that we have our LED count set, Control O, enter, Control X. So now we can execute this by doing sudo python 3 examples /strandtest.py. But that means we got to go back to the bench and set up our Pi so that way it actually is connected to our LEDs. Now we want to shut down because basically we're going to be doing some rewiring to get this ready to control these LEDs. Sudo shutdown -h now, and it's shutting down. Alright, see you over at the desk. Alright, so back at the desk, we've got a few things going on. The Pi, the connectors that came with the strand of LEDs, and the buttons. The buttons we can set aside for now because it's not where it's required to test the strand. Basically, I'm going to figure out how we want to put this together first. What we could do is, since this leads through here and these are connected, the power pins are connected, is have this go over to the Pi, and then if there's any problems with the Pi or with the strip, there I can separate them. And then what I can also do is put the main line into this for power. So it'll basically divide the power out as needed. So in my haste, I forgot to bring you along for the ride, but to let you know what's going on, these pins here, this pin and this pin, are the 5-volt line. This pin is the ground, and then the sixth one down, 1, 2, 3, 4, 5, 6, is the data pin that we're going to be using, GPIO 18. And so what I did was I bridged these two, attached them to, soldered them to the connector make it so we can remove the strand if needed. This red line is the positive 5 volts. It goes on the back because that's how it's going to come out of this shell. It goes across the 2 5 volts to kind of help distribute the amperage across it. Then we have our white, which is our ground on the ground pin, and then I'm about to solder in the data pin. And we're going to do that by tinning this first. And then again, 6th one down. 1, 2, 3, 4, 5, 6. So I'm going to put that in the hole there. And there we go. We now have our power out to the board and the data coming off of the board. Put our SD card back in and take this and put it through there and into the shell. And I can actually take this, put that on there. That's our Pi now. Alright, so now that we've got our Raspberry Pi all hooked up, we can actually connect it together with our strand. And then we're going to connect back up to the benchtop supply just to test this section out first. What we're going to do here is I'm going to apply power to the Pi and the strand with the benchtop supply. Pop this open just to make sure it's getting power. Yes, it is. Actually, I'll leave that open just so that way I can see what's going on. We're going to run the test code. We need to do cd RPi underscore WS2812x/ that works. All right. Then you want to do cd python. So we're in the RPi WS2812x/python directory, and then we want to test the strip. So that's going to use sudo python3 examples/test. There we go. Oh, that's super cool. All right, so I set up a quick test. I went into the examples folder and found a white test and had them all turn to white, which would be the highest power usage. And so what I'm looking at right now is we're drawing about 4.33 amps, which is nowhere near the 10 amps that it was talking about. And these are turned on full brightness, so I'm thinking that means I can switch to this smaller adapter and still be okay. So I think that's how we're going to move forward. That means we can start installing this on the back of the Dino and move forward from there. We can do our further programming later, but that way we have the base of the smart light put together and powered. So we're going to go from there.